So I plotted nearly every major train project across Southeast Asia by how much it costs to build. If you take a look at the top of the list right here, the three dots are Singapore train projects. They cost an insane amount of money, one being over $1.6 billion per kilometer. Yeah, you heard that right. 1.6 billion just for 1 kilometer. But that's because it's Singapore. It's among the world's most expensive countries to build in. But then, beyond Singapore, there's two more dots at the top of this list. And as shocking as this may sound, they come from a country that shouldn't be expensive to build in. And that's none other than the Philippines. In Manila, two train projects sit near the top. The Metro Manila subway, ranked as the fourth most expensive, whilst the shelved Makati line, ranked as the fifth. At $764 million per kilometer, it made me question so many things. Why is it so expensive? And I figured the answer will be simple. The city floods, it experiences a lot of earthquakes. And it might just be a difficult place to build. But that can't be it. Because if floods and earthquakes are what makes a train expensive, then every train project in Manila should be expensive. And they're not. If we go back to that chart and highlight all of Metro Manila's train projects, we see this. There's actually a couple of train projects in the capital region that sit among the cheapest in Southeast Asia. The cheapest one is $214 million per kilometer, which proves my initial assumption that Manila is just expensive to build in was wrong. So I wanted to know the answer, the real answer. Why is that specific train project, the Metro Manila subway, so insanely expensive? Expensive enough to sit right behind Singapore, one of the priciest places on earth to build. Well, I went to search for it and I found it from the same source. Here, laid out again as a scatter plot, but instead of using the x-axis as kilometers, it now shows tunnel percentage. This just means how much of a line runs underground. Underground being a subway while not underground an elevated one. And the two most expensive Manila lines, 100% underground. And the cheapest ones, they are almost entirely above ground, or as I just mentioned, elevated. So the cost was not because of some unknown reason. It was actually never about Manila at all. It all came down to one thing. Does the train go over the city or under it? And the reason is simple. Let me show why. When you build elevated, you stand a column up on the ground. Then you lay the track across the top. And the city underneath just keeps going. You build above it. But then underground should be a lot simpler, right? All you have to do is dig. But it's actually far more complicated than that. In fact, beneath Metro Manila is a crowd of water pipes, sewers, power lines, and the foundations of every building. So the subway can't just go straight down, it has to tread around all of it and go deep. I actually wanted to show you a map of Metro Manila's water pipes, sewers, and power lines together, something that could show us just how difficult it is to build a subway here. But I couldn't find anything, and as I was searching, I found this, a diagram published by JICA. When I first saw it, I wasn't sure it'd be the best fit, until I sat with it for more than an hour to understand it. So let me guide you through what it shows. The top line, that's the ground, the surface of Metro Manila, hills, buildings, and all. And these labels dropping down are the streets it passes under. North Avenue, Quezon Avenue, Katipunan, Ortigas, all the way down to the airport. This red line underneath is a subway, and it doesn't go in a straight line. It dives, levels off, and dives again, threading its way under everything above it. Right here, near the Pasig River, it drops to its deepest point, tunneling beneath the river itself. But the part that matters most is down here, at the bottom. These are the stations, and the numbers are how deep each one goes. And this is the part where it stops being abstract. They start around 18 meters. But most sit in the 30s, and the deepest, 39.7 meters. That's almost 40 meters underground. To put that in perspective, 40 meters is about 13-story buildings. Now picture digging that down instead of building it up. Beneath the roads, treading under the pipes, the sewers, and the foundations of the city already standing there. And that's just one station. The subway has about 17 of them. So here's the obvious question. If underground is this brutal, this deep, this expensive, and this slow, why would Manila build it at all? Why not just do what the cheap lines did and put the whole thing up on pillars? Build elevated everywhere, save billions, and go home. And that's exactly what I initially thought. I figured, isn't it stupid to build a train that costs more than $760 million a kilometer when you could build one for probably half the price? But here's what stopped me as I kept researching. The cost of those cheaper lines is actually hiding somewhere public data doesn't show. And to find it, I had to dig into the project's own planning documents. And there it was. Because before they built this, they actually compared the two options head to head. For one stretch of the line from Quirino Highway to Tandang Sora, they priced it both ways, elevated or underground. And the elevated one was priced at 4 billion pesos, while the underground stood nearly 8 billion pesos. That's half the cost. So the choice is obvious, right? Well, the same table that gave us those prices showed why it wasn't. Because when you build elevated, you build pillars everywhere. Massive blocks of concrete planted across a dense city. And those pillars need land. They would affect 148 structures to build the elevated route, versus just 54 if they choose underground. Now here's where it gets strange, because you'd think building underground at least gets you out of the land problem. The tunnel is deep, below the ground, out of sight, and nobody up top even knows it's there, right? Well, wrong. Take Corinthian Gardens, one of Manila's most expensive gated subdivisions. The subway doesn't stop there. No station. It doesn't tear down a single house. The tunnel just passes underneath it, 500 meters of it, deep below the ground. And the government still had to pay 33 properties, over 820 million pesos. That's an average of around 25 million pesos per property, just for a tunnel passing deep underneath them. A tunnel where these homeowners may never see. So why pay for a tunnel nobody will ever notice? Because in the Philippines, when you own a piece of land, you don't just own the surface, you own down. By some interpretations, your property extended as deep as 50 meters into the ground. So a subway tunnel sitting deep under your property, that's not really underground. Legally, it's inside your property, which means even buried that deep, the subway was still running through land that belonged to someone. And this turned into such a problem that in 2025, the government actually changed the law. A new act that said for priority infrastructure projects like this one, surface owners generally can't block the use of the deep underground, below 18 meters. Just so I don't cause confusion, this act does not erase property rights, and compensation are still given where structures can be avoided. Now, all of this points to one thing. Building underground here is never simple. But these problems, they're just the beginning. Because in a city that floods, that sits on a fault, and that never stops growing, every problem above the surface becomes a cost below it. Let's start with the water. Manila floods badly every year, so a subway here can't just be waterproof. Every entrance, every station opening has to be built like a barrier, lifted above the streets, sealed, ready to hold the water out. That's cost the cheap elevated lines will never pay. Then there's the ground itself. The line runs right alongside the West Valley Fault, one of the most dangerous earthquake faults in the country. It doesn't cross directly over it, but it runs close enough that the whole thing has to be engineered to survive a major quake. Japanese seismic design and disaster prevention systems built to keep trains safe when the ground starts shaking. And it's not just the fault. The tunnel crosses at least 11 rivers and creeks underground beneath the water. So everything that makes Manila Manila, the floods, the faults, the rivers, the damn city on top, doesn't make the subway a little more expensive. It stacks, one cost on top of another, until you get a number that looked almost impossible, $760 million a kilometer. So it's expensive, super expensive. But then the part everyone wants to know, is it even worth it? And that's where it gets interesting, because there are actually two ways to answer that, and they completely disagree. The first is the economic return. Does the subway make sense for the city? Less traffic, hours saved every day, less pollution, faster trips for millions of people. And on that measure, the answer is yes. JICA's own evaluation gives it a positive return of about 9%. For society, it pays off. But then, there's the financial return. Does the subway make sense as a business? Can it earn back what it costs to build through ticket sales? And there, the answer is no. The financial return is negative, minus 1.8%. Or to put it simply, the train will probably never make its money back from fares. So, is it worth it? Well, it depends on who you ask. As a business, it's a loss. As a city, it might just be one of the best investments Manila ever makes. And that's a strange truth about big infrastructures. The things that are most worth building are often the ones that could never pay for themselves.